Now we'll look at three examples of evaluating log functions using the change in base formula. And for these examples, we'll be using the common log when using the change in base formula. So this first row is an example already worked out for us. So our first function is h of x equals log base 7 of x. We want to determine h of 5/8. So for h of 5/8, the input is 5/8, so we'll substitute 5/8 for x, giving us log base 7 of 5/8. To turn this into the computer, if we click in the answer cell, a small yellow arrow will appear. If we click on that small yellow arrow, this math palette appears. If we click on the Functions tab, we can use log base n to enter our logarithm. When we click on log base n, we can change this base to 7. And then we can also use this fraction tool to enter the fraction. Now for the next step, we want to write this as a quotient using the change of base formula given here. And because we're asked to use log base 10 or common log, we'll use the fact that log base b of x equals log x divided by log b, where we're always taking the log of the number in the numerator and the log of the base in the denominator. And the change of base formula is true for any base logarithm. So sometimes we'll see this written using natural log x divided by natural log b. And these are the two most common logs used when using the change in base formula, because these are the two logarithms on the calculator. So using common logs, we can say that this logarithm is equal to log or common log 5/8 divided by common log 7. And again, to enter this into the computer, we would click in the answer cell, click on the small yellow arrow, then from the General tab, use the fraction tool here, then click on the Functions tab, and then use this option here for a common log. And now we'll evaluate this on the calculator. So we have log 5/8, make sure we close the parenthesis here, divided by log 7, close parenthesis, and enter. But I also want to show we can get the same value using natural logs. So if I press natural log 5/8 divided by natural log 7, the result is the same. So we can actually use any base we want when using the change in base formula. To 3 decimal places, this will be approximately negative 0.242, because this 5 in the 4th decimal place indicates to round up. Next we have p of t equals 12 times log base 6 of t. We want to determine p of 24. So that would be 12 times log base 6 of 24. And when applying the change of base formula, we're only applying it to the logarithm, not the 12. And since this means 12 times log base 6 of 24, we would have 12 times common log 24 divided by common log 6. And now we'll evaluate this on the calculator. So we'd have 12. Again, I'm going to put this whole fraction in parentheses. So open parenthesis, log 24 divided by log 6. Close parenthesis for the logarithm and close parenthesis for the fraction, and then enter. So p of 24 is approximately 21.284. Notice the 4 in the 4th decimal place indicates to round down. And for the last example, we have f of x equals 14 plus log base 3 of x. So for f of 193, we'd have 14 plus log base 3 of 193. And now applying the change of base formula, this would be equal to 14 plus common log 193 divided by common log of 3. Going back to the calculator, we'd have 14 plus common log 193 divided by common log 3. To 3 decimal places, this is approximately 18.790. hope you found this helpful.